Cool. So yeah, I really love what we have heard so far because it's touching a couple of points that I'm going to talk about today. So it's easy when you're just like listening to some like tutorial or even like here on a talk, how easy it is to get like GraphQL, getting it up, getting it running, getting your first responses out of it. And that's exactly how I've started with it as well. But quickly you will realize that there's like no perfect world and you will have like some errors. And that's why we are here today, because dealing with errors is not always the nicest thing to do. And I want to try to convince you that it makes sense to like treat them consistently, treat them like from the very ground up, and don't think of them like as a second-class citizen just after you have implemented everything. So as mentioned already beforehand in here, that's why I really like the partial success will be also making it just more difficult to deal with them consistently, especially if you're going towards like monitoring or things like that. You cannot rely on the same systems as beforehand with your REST APIs and, you know, the alert on a higher level of 400 responses, because there might even be failures within your 200 responses. So why I'm actually the person sitting here and talking to you about that. I'm an API developer for about 5 years, I would say. I mean, I have been working on APIs and with APIs beforehand, of course. But since I've joined Contentful, I am considering myself more as an API developer because the company is like API first. In 2018, I started picking up GraphQL just like on the side, just for me experimenting around. This was like a very intriguing technique and it's up to today. And at some point, we started a project at Contentful using GraphQL. We didn't have like much experience with GraphQL prior to the project, except for my place that we had beforehand and like some other colleague who had built like a rough proof of concept, just basically using the REST API. By now we are on a like native GraphQL that's like not using REST in the background, at around 4 billion monthly calls, a code base that I have heavily contributed to and I'm maintaining up until today. And the cool thing about that is that we're actually generating a couple thousand schemas every month, because every user can have their own data model, and based on that, you get your own GraphQL API. I've actually covered that in like one of my other talks beforehand. And this is like a very specific thing, which is not up for today. So what we will be looking at first is the GraphQL request lifecycle to get like, when we are sending a query and we've just sent like this string of text and we get some data back, what is happening in the meantime and what are the points where it could go wrong? The first one that we have is the transport layer. So as was mentioned beforehand, we have like GraphQL as like transport independent. You could use like via WebSockets with the subscriptions. You could theoretically use like gRPC or something like that and serialize your data, but most often is actually used via HTTP, and that's also what we will be focusing for the like examples here, because that's the only thing I've been really excessively working with. Error examples here are things that happen before you even reach the GraphQL part of your server. You might have like some constraints on your request payload size, like the query string might get too long. You might have a custom post body size. We have, for example, so that we can guarantee that your request will be cached on the CDN. Those things need to be considered beforehand and might be their own error cases, but you still want them to be formatted in the same way as all your other errors are. For example, as well, if you're running into authentication problems and you're actually having like no authentication at all, you're sending an invalid token, maybe even things like you're running into rate limiting and some other service beforehand is returning the error. But yeah, that won't be covered here because we're actually looking on a error pipeline on the server and not like on the CDN beforehand. Once you get to the actual GraphQL server, the first thing you have to have is like a schema. Here it's like the tricky part at Contentful. We have a bunch of schema level errors, like when we're generating a schema, because we're generating it from like customer provided data, and that can go wrong, of course. Most of you probably won't run into this, or if you do run into it, it will be covered by your tests, because you're probably dealing with just like a single static schema. And when that thing fails to generate, all your tests will fail, of course. An interesting thing here was that actually GraphQL requires you to have a type name starting with an underscore or like A to Z. So you cannot start it with a number. We had types that could start with a number, and we had to make sure that we like prefix them so that the generation still works. You could have like naming clashes that can happen even like when you're using a single static schema, that you just like made some mistake somewhere and you have like two types that are now having the same name or resulting in the same name. These are prior to the execution, but it is like after you have actually received the message. So let's go one step further. Document parsing errors. What is a document? A document is what GraphQL uses to evaluate your query. You send it a string. The string gets parsed into a document. And that means that you're like tokenizing everything, and you try to make sense of it like from a syntactic way. Like GraphQL has a specification of the language, and if you don't match its syntax, there will be failures. That is independently evaluated and not using your schema, because it's just like, it's not making sense out of it, it's just the syntax. And if that fails, then most likely your customer or your user needs to be needs to change the request to make it work. Example or simple examples here are just like, you mistyped queries, just like a typo. Here, like the E is missing. Or you're sending parentheses for arguments, but you're actually not putting arguments in there. GraphQL as a language says this is not okay. And this is handled by the GraphQL engine in whatever language you are using. In the later state of the talk, I'll be showing you some error implementation or error pipeline implementation, which will make use of the GraphQL JS reference implementation, utilizing some TypeScript. But no worries, if you don't know TypeScript, that will be fine. I will walk you through. Once we have parsed the thing into a document and we know that it's like syntactically correct, GraphQL tries to make sense of the document and what you're trying to achieve. It does that by applying some default set of validations you could remove, but I don't recommend you to do so. And for example, it is enforcing that a fragment you have sent in your query is actually used. In the error example down here, you will see that is like not the case. You're not using the foo fragment. So GraphQL might decide to just like send you back an error being like, hey, that fragment is unused. Could also be, I think, if you are trying to use fragments on types that are not supported. That is validated against a specific schema. So you don't know what type it is, what type a fragment can be used on if you don't know the types of the schema. So it has to be validated with the schema. You can put your own validations in there if you want to, and I think one pretty common thing to do so is for the schema complexity. So if you, I think we have seen that as well when Raphael was showing the, I think it was Raphael showing the directive implementation. Those things can throw errors, and you want them to be handled in the same way as all the other errors. Streamline them so that you see it. And then the meaty, juicy part, the execution phase errors. So actually everything that is like concerned with your business logic, some database request failed, something wasn't found. Maybe even the custom scalars that we have seen in one of the two talks beforehand as well. If we send like I think that's the US style of sending a date, which cannot be represented as an ISO date, you only know that once you have executed the code, like the business logic, that is defining what a date looks like. This is like the most frequent thing you will run into, and you will want to make sure that all of them make sense to the user. So why do we actually want to do that? Because we want to walk the user somewhere. We want them to know what is going on. So before we can think about why we actually need to do something custom, we should maybe know how a GraphQL error actually looks like, which we will see here on the slide. So there's like some data and maybe some errors, and the errors look like this. This is like the minimum viable GraphQL error, basically. You have some message and you have like some, I think even locations and path are optional, but they're most often added by the GraphQL error, like the one that is coming with the reference implementation, and we'll be talking about that in a minute. This error in itself is not really useful, is it? So what actually makes an error useful? The user has an idea what went wrong and where. This is why there is like the location and the path. So you know where you have to look in your query or to see what might be going on. you want your user to be able to make an informed decision on what to do next. What to do next can be as simple as retrying, or it might even point your user towards that they need to change their query to be able to repeat it and then be successful. Bonus points if a machine can reliably work with your error shape. For us, that's pretty important because we're an API-first company and we want customers to be able to integrate with our API and handle the errors by a system they have developed. So what you can do to make your errors more user-friendly is, first of all, to use only specification-compliant fields. That is a bit contrary to the other approach we have seen beforehand, where we actually maybe mix the errors into the data object and so on. To be honest, it's the first time I've heard of it. It's kind of interesting concept, but I will stick here to having the errors and the actual successful result in the data properties. Within an error, you only want to use specification-compliant fields as well, so that you make sure that everyone can handle the error that comes back, because it is not as strictly typed as we have heard. You should make sure to use the available fields from the specification if you have them at hand. So if there is something going on that is not, that cannot be pointed back towards the location or path, it's of course okay to leave it out. But if you do know in which specific section of a GraphQL query something went wrong, it should be in there. And then there's like this nice extensions field, which is like a free form record where you can just put basically everything in or anything in there that you want. My recommendation here is that you use a namespace with a key that won't clash with other APIs, because they can be stitched together. And if you, for example, combine the GraphQL API from GitHub with Contentfuls, you want to make sure that if one of the two is failing, it doesn't override the others. So we decided to put everything into the Contentful namespace. Another thing that we found pretty much lacking from the specification is like a static error code. The message, in our point of view, is more towards the human readable form. And you might want to change the wording if it's necessary. You might want to put more information in there, whatever. So we said we want to have a static error code that never changes, because we're pretty serious about backwards compatibility. So once you have that static error code, you can always look on that specific field that has an error code and react on it as you wish for. And last but definitely not least, add a request ID. Like seriously, add some sort of request ID that makes it possible for your engineers or support engineers to be able to find a request again. So at some point, a customer reach out having problems with specific requests, and you want to be able to guide them or like ask them to send you the request ID and have like some more information in your backend system. So with that knowledge, this is how useful yet GraphQL specification compliant error looks like. And as you can see here, we have put in there the extensions with Contentful, and now we have like a code, internal server error, and we have a request ID that you could send to support and ask what is going on. This is even better, because now that we have like this namespace, we can put in there whatever we want. We can help the customer. We can guide them towards what they should be trying or doing. Here we say, like, sorry, this locale doesn't exist that you wanted to get data inside of. So instead of just saying like, yeah, it didn't work, we actually can put details on there and point them towards, hey, there are available locale codes, and those are those two. German is not one of them. Please choose one of the two, and it will be successful. The customer can change the query and will be successful. So where does actually this information come from? Like the location, the path, everything you have. There is the GraphQL error type. This is the one I was mentioning shortly earlier, which is shipped with the reference implementation of GraphQL, like the GraphQL JS. What it does is, it is encapsulating other errors. And I know this is like a bit overwhelming maybe, so let's walk it through it step by step. The GraphQL error has a message as well, which can be like this human readable error message. In the approach I will show you today, it is actually not as useful to have the message field because we are trying to combine errors from that might be happening before GraphQL kicks in to the point where GraphQL is used. And we will be implementing our own error type that will be used afterwards. Nodes and source is like this parsed string to the document that I was talking about. And in my point of view, is mainly used to be able to pretty print errors while you are developing, and it shows you like where in the query something was going on in a visual way. The same with like the position in the past. That is derived from at which point in your GraphQL document you are. If you create that error by yourself, you would need to put it in there by yourself. But everything, for example, that throws within a resolver will automatically have this data attached because the GraphQL engine knows at which point in time which resolver you were working on that failed, and the customer will be able to look at exactly this portion of the code of the query to make sense out of the error that was coming back. And the most interesting thing is the original error. You can wrap, like the GraphQL error wraps another error type that you have, and within that error, that is completely up to you what you are doing. And we'll be utilizing this approach so that we can streamline it from start to end. And then lastly, there's also extensions. You can use it, and you can use it together with the message thing and basically rely on the GraphQL error to handle everything for you, which might sound intriguing and easy in the beginning, but as it is not as strictly typed for us using Typescript, it wasn't so good to actually use it. We couldn't enforce that specific information is present on an error. So we decided to actually just use the original error and then apply some formatting for us at the end of a request after everything has happened and executed. So yeah, bring your own error. For us, it was the approach was that we have this original error, and inside this original error field, we usually have like a Graph API error. A Graph API error can be created from outside, like when we like before the execution started, but we can also throw it from within a resolver, and it will be wrapped in this GraphQL error, and we can still make use of it after the request execution has finished. So for example, not for example, but what we are doing here is we are saying every error encapsulates a specific problem. Like, what is a problem? A problem is everything you know in your code base that could go wrong. And here it makes sense to just like step a bit back from your actual implementation and you're hacking everything in and then you're thinking about errors. But maybe think about it up front. When we were designing our first API that had to work with like hundreds of different customer data, how they defined it, we were, before implementing, we were thinking about what could go wrong and in which forms, which sort of problems are they, how do they relate to each other. And in a very simplified form, we came up with this execution problem here, which might be things like the unknown locate that you've seen beforehand, or like an unresolvable link. If you're linking from one resource to another, but that link cannot be resolved on the database, then you might want to show like here, at this point it went wrong. And we have also query validation problems, which are like a step beforehand, like before the query is executed. So for example, on the transport layer, if the transport layer didn't receive a query, we don't need to attempt to execute it. We can say, hey, we have a missing query, and we can abort already. The same for like query formats that are invalid or variable formats that are invalid. And once you've thought about all of them, it gets pretty clear for you where in which position something in your code base could go wrong. And that confidence is gold, in my point of view, at least. Once you have that, you can like join them together. As I said, you don't need to necessarily know Typescript for it, but it is basically a union between like different types that you have. And it says like a problem can be all of those different problem types that you have. These problems will be passed in when you are creating an error and will just be assigned to the error so that you can use them later on for formatting. Cool. So, for example, with the unknown locale, we had additional information on that, right? So how do we actually store additional problem information on it? We do that by having a distinction between the error codes, as seen here on the top. Those error codes are unique, and they are static or stable, however you want to see them. So we won't change those error codes. That makes it pretty useful to use them in a so-called discriminated union, which basically means we have objects where this problem kind here is on a specific property, and based on which problem kind value it has, it knows which type it is of. So, for example, the missing query has nothing else to it, so we don't need to define any type, how it would look like. But for the unknown locale, we have the available locale codes and the actual locale code that was not found, so that we can format the error message properly. So we put the kind, problem kind, unknown locale here, and by that, the Typescript system can figure out that whenever we are creating an error and saying the problem kind is an unknown locale, it will even be enforced by the type system that we put an unknown locale code there and an available locale codes. The same is here for the unresolvable link, just has like a bit more data because you need to say from where it points to where and what kind of type those references are. But here again, it has the kind, problem kind, unresolvable link. So once we create an unresolvable link problem, it will ask us to fill out all the other values as well. This is pretty useful and actually makes sure for us that we are always sending out the exact same shape of errors, because if we wouldn't send them out in the same way, for us, that would be a breaking change. So we can rely on a bit of type safety here as well, which makes it easier. So when we are creating an error, we are basically passing in an object because we define just interfaces. And the interface says, well, a problem always has a kind property, which is like this one of those problem kinds. Missing query has no other type built around it, like no additional information. So you can just throw it in there as a kind and you're done. When you want to do that with the unknown locale, you will be forced to put in the other two here as well. But in the end, it's still all those problems are just like objects that are in a well-known shape. So that one here is how we are formatting problems to the GraphQL specification errors, because we want them now, all those Graph API errors, we want them to look like specification compliant errors with as much useful information as we have. So we can basically just check on it. After we have went through the request execution in GraphQL, we will have like the data in the errors array, and we can just go over the errors array and say like, hey, first of all, is it like a GraphQL error that wraps anything inside? If not, we probably just want to put out some generic error handling so that we don't leak any information. But otherwise, we will probably look on the inner error that is encapsulated and can check on that whether it's a Graph API error. If it is, we can format it as specifically. If it is not, we just make like a generic error message, as I said, to just like clean out or make sure that we don't leak any information to the outside that we don't want to. So it is probably more important to look on those two things here. How do we get to the message? And how do we actually get the extensions object that we want to send out? It is basically as easy as a switch statement. And you can even put like an error throwing thing at the bottom if you wish for. But actually, you would never be able to construct a problem that has not a known problem kind if you're using Typescript. So for the missing query, we don't have anything interpolated in there. It is just a static string, basically. But for the unknown locale, we can interpolate things from the problem into it. Typescript knows, because we have used this case, the case unknown locale, it now knows that the union type of the problem that you have chosen is the unknown locale one. So it knows that you have an unknown locale code and even like the available locale codes that we can then use to format everything. So here, that is how it would look like for a generic case, like the missing query that has like nothing else, like no details. We can just return it, put the request ID there. Please put the request ID there, like really. And otherwise, we can just pull out the details, everything else that has been on there, and put them onto the details object. If we do so, now we will have the available locale codes on the error message, and yeah, the user who sees the error, or even a machine who reads over it, can make use of the information. Well, yeah, as I have said earlier, we weren't using the GraphQL error that was shipped with the reference implementation. because it had like none of these type codies that we were just talking about. But what that also means is we have to make sure that we actually copy over the location and the path if they are available on the outer error, so that they are now on our GraphQL error, like the specification of the GraphQL error in that JSON, it should be in. So we have to manually add them. That can be literally as easy as this. This is like copied out from our current production code, more or less. Of course, wrapped in like some other fashion. Yeah, once we have that, everything is sent out, everything's cool. As I mentioned in the beginning, we want to be differentiating between unexpected errors and expected errors, because there will always be unexpected errors. There might be, I don't know, a dependency has been updated and is now throwing some other sort of error. That might still happen and won't be wrapped in one of your problems. So those kind of things you would probably want to yell about very hard. You would put them like to Sentry, some error monitoring, whatever. But if somebody used a locale that is not known, you know that this has been handled. So why would you bother spamming all your logs with it? Like your log pipeline gets bigger, like your metrics maybe even get skewed because you think you're having a bunch of errors, even though a customer is just like trying something out against your API. Also, there might be multiple errors in a single request, and then you will have like the problem over and over again. So if you have like, I don't know, within a collection nested something asking for a specific locale, and you have it like a limit of 1,000, then you will have like 1,000 times the error that the thing is not, like the locale is not known. And like 1,000 times the same information logged. This can really heavily clutter your log pipeline. And if you're like at 4 billion requests per month, this gets at some point even expensive. So it might be cool even to look at it from this side and to optimize how you want to handle what is going on. So my better solution here is to just react differently if you know the problem. Like if there is a Graph API error, if it's not a Graph API error, then you want to capture it on Sentry. You want some developers to know about it. You want to figure out what is going on. But if not, you might want to do either nothing or maybe increase some statistics counter so that you can still look at in relations how many errors are occurring. For example, you could then judge by yourself whether it is just an increased error level because more people are picking up your API or because something was breaking in your last deployment and now suddenly you get 10 times more errors. Yeah, that is more or less the approach we are taking. And towards the end, of course, there are some limitations or pitfalls that you can run into. The one that was biting me the most is the first, that scalars, like those custom scalars, as we've seen with the date parsing, they often throw a usual type error. Like as if you would have mistyped something in your code and it says like, I don't know, type error cannot read property foo of undefined or so. Those are things you probably want to bubble up and check, have been checked by your developer. But if a customer just sends a date format that is not valid, you don't want to be notified about that in Sentry. So yeah, how do we deal with that? Same goes for like custom validations. The complexity library we have been using is creating its own error inside, which was not very much of use for us and was actually lacking some information we needed. So luckily, this implementation allowed us to create our own errors. And that is, of course, the ideal solution, right? You just replace the error creation part and just throw or return some Graph API error with a known problem inside. So for example, like the problem is that the query is too complex. For the scalars, that is often not possible. For example, on our date scalar that we are using, like an outside module for it, we cannot change that. What you can do is you can basically pick those functions from the custom scalar for like parsing or serializing. You could wrap that to just like catch very early when that scalar is failing and return it as a Graph API error as well. That can be a bit cumbersome depending on how many custom scalars you're using. But I would recommend you to actually also think about that because we haven't initially, and it was a nightmare to see all those Sentry errors popping up in our Slack. That actually was it. I'm very happy that you bared with me here. And yeah, time for your questions. Or if you don't feel like asking in the stream here, you can reach out to me on Twitter. The handle is linked in here. And with that, I appreciate that you've been sticking with me. Thank you.
Well, Stephan, that was really great. And I must say, I've heard here one of the best advice in GraphQL presentation ever with the request ID. So that's really great, and thank you. That's a lifesaver. So that was really good presentation and a lot of content. And we did have some questions from the audience during the presentation that I think you might have at least partially answered till the end, but we'll still give it a go so we can clarify and elaborate on them. So first one is, where do you see the line dividing events requiring errors that appear in error data, like in error objects, and unwanted behavior that would be better served by first-class GraphQL schema citizen type, like in a regular GraphQL schema?
Okay, so that is, I think, basically coming back to what Rafa was saying in his talk, right, where he was like putting some like GraphQL schema citizen types, basically putting them within the schema. I would actually like if there would be like typed errors in GraphQL, but it's like not there from the spec. And yeah, we are always trying to stick as close to the specification as possible. I have only heard about today that people are actually putting it into data, so I don't have any experience around that. For me, it kind of sounds okay if you are for mutations and things that are actually write operations. The result of that being in the schema, and like you see errors when you're trying to create something, always with the same kind of structure. That could make sense, I think. I will definitely read up into this topic afterwards because it's I only learned about it today. It's really interesting that people are tackling it like this, because we were struggling, of course, as you can see, with how errors are treated in GraphQL, and we built like our pipeline to actually make sure that they're like streamlined. And yeah, just putting more types on them by having them within the GraphQL schema actually sounds very intriguing.
Yeah, okay, great. Actually, we found that doing those typed returns with those behaviors in the mutations is exactly what is useful. And I think there's a lot of this content in such a presentation that Rafa put in his slides. So I encourage everyone to look into that because it's a very good presentation too. Let's go to the next one, which is, you've mentioned a unique ID during your talk for identifying errors. Can you tell what solutions or products are you using for tracking those? Example, is it Sentry?
For the known errors, it's not Sentry, because we try to use Sentry for like things that are really hard breaking. And if we have a unique error code assigned to the problem, we obviously know about the problem. So what we are doing for some of them, we are like putting them into the logs, because we might want to log some additional information that shouldn't be disclosed to the customer, so that we can make more sense out of it, especially during like internal server errors, or when we actually hide an error and just put out the internal server error. We want to be able to look it up afterwards, and we just put them into our logging system. For the known error types, we're actually using some like, in a simple way, just call it like statsd, like some statistics service where we generate a key out of it, like, I don't know, GraphQL error, and then like the error code. And then we like increment those values so that we can track them over time. There's also potentially like log analytics pipelines that you just like send out data tracking events if like some of those errors happen, and then you could use, for example, systems like Redash or so to make like visualizations of the errors that are coming.
Okay, great. Thank you very much. Okay, I think we've got another one. Yes, we do. Do you support federations? How are those standards extensions, GraphQL Error, would work with federations? If they are not defined, would it be a problem?
I'm not sure what you mean by if they are not defined. Like federation in itself actually would work really well, I think, because you could have in different systems having different errors, and as they are nested in under their own namespace in the extensions object, then you could just like merge them all together. You could just merge multiple namespaces in the errors together. So that would work pretty well. The extensions field is part of the GraphQL specification, as far as I know. So federation should totally work with it. I think it would be pretty useless if it wouldn't support it, because you couldn't send any information across the federated schema if you only are sticking to the message. Or it would be very hard, because you would always need to do string parsing on the message to be able to figure out what is going on. But that being said, I haven't worked with federation much.
Okay. Would you consider sharing some code between services in federation that pack those error messages and do the layout a similar way, or just follow the convention, or maybe do it some other way?
Depends on how you are doing that. Like, I mean, if they're like all in the same kind of language, you could of course think about some package that abstracts this away so that you can like use it between different services. In a polyglot system, you would probably just stick to this is like our own specification of how an error within our company looks like, and then your different languages would need to implement it to stay consistent.
Sure, that makes perfect sense. Thank you very much. Okay, so I guess that's it. Oh, no, that's not it. There's another one. Do you attach unique ID to every request or only for errors?
We do that for every request, because sometimes we might want to debug like slow requests, for example, that was still successful. In fact, when a request hits our network, we will be assigning a request ID to it that we can then like follow through our whole server infrastructure. And we will be serving that back usually on a header. But like for the errors, we are also surfacing them so that, because when you're having an error, you're more likely to need to use that request ID. So we're putting it very explicitly in there so that you can easily copy paste it out without looking on any like transport specific thing, because GraphQL is transport independent. We decided we put it inside. We don't rely on that somebody looks on the HTTP response headers to be able to figure it out.
Okay, thanks. And that's it, I guess. That's a lot of questions. Thank you, Stephan, for everything. It was really great.